Hello, everyone, and welcome to What's Up, the podcast where we talk about everything electrical and the future of the test and measurement industry. My name is Darcy, and I'm here to discuss some of the industry's biggest topics. Trending in the electrical industry is important not only to see the past performance of your asset, but also to help predict its future. In this episode, Dr. Diego Robalino and I discuss all the practicalities of testing for trend analysis, but also the importance of validating the data. So let's find out what's up with Dr. Diego Robalino. Dr. Diego Robalino, welcome to the Megger What's Up podcast. How are you doing?
Doing great. Thank you for inviting me.
Absolutely. A pleasure to have you as always. And as you know, we usually start the podcast with something we call the power up questions, which is just no need to panic. It's just quick fire questions so we can get to know you a little bit more and get your brain switched on.
I thought there were only 3 questions like that. Now you're talking about 5?
Did I say 5?
Did you say 5?
Oh, my mistake. It's definitely 3. I'm not going to stretch you to 5. Don't you worry. But are you ready for them?
I hope so.
Okay, good. They're easy to answer, I promise. Okay, question number 1. What was the last conference you attended?
Actually, we just came back from the Secret 22 in Paris. That was a fantastic event. The Megger team put a fantastic booth. The people, the exhibition, the papers were great. I mean, different topics on different areas of the electrical technology, the electrical theory. From power generation all the way down to digital technology and protection and distribution of systems. It was really a wide spectrum of topics that were discussed. We were able to participate there with a paper that we presented, a paper with Dr. Peter Borelius and our good friend from Hydro-Quebec, Ismael Gunner. So we were talking about bushings, a little bit about different conditions, environmental conditions and operational conditions that may affect some testing practices. So it was great. We had the poster session. We had many people just walking by, asking questions, and we were exchanging information. But I think that the best is just to get back to this.
Yeah, great to be back, right?
Great to be back, and everybody's a happy face. Just meeting the old friends and making new friends. I think that it was a fantastic experience.
Great.
Overall. Yeah.
And you've just mentioned something that is actually question number 2, which is, what is your favorite paper you've ever published?
Oh my gosh.
I know you've probably had a few in your time. Yeah.
There's quite a few. But I think that the paper that brings me more feelings, I would say, it's closer to my heart. It's the first one that I published while working on my PhD, right? As a student at the university in Tennessee, it was just nice to work with my advisor and just start working on these papers for IEEE. And I think that very first paper as a PhD student is the one that brings more
it's
feelings.
Nostalgic for you, I can imagine. And question number 3, what is your favorite ice cream flavor?
Well, just to let you know, I like gelato very much, right? And if we go
They're 2 very different things, aren't they?
Well, yes and no, maybe. But if we go to a gelato place, I would like to have some pistachio gelato.
That's exactly what I'm ordering too. So.
Oh, good.
Absolutely.
So we're synchronized there. Yeah.
Absolutely. But we're not here to talk about ice cream. We're actually here to talk about trending in transformers today. So Can you just tell me what is trending? And then how does that kind of fit in with transformers? What is it in the transformer context?
Okay, trending is part of the diagnostics. Trending is something that has been commonly used for the analysis of the life cycle of the transformer. So think about this. Even though we look at the transformer and it's copper, aluminum, iron, I mean, there's different materials, different metallic materials, different components. Inside, the life of the transformer is based mainly on the insulation system. And the insulation system is organic materials. So we cannot deny this part. And by saying that, we understand that any organic component will age. Right? So if we're looking into life cycle, even normal operation will make these components, these materials to degrade. And degradation of the insulation system can be looked in a historical spectrum, let's put it that way. So from day 0 at the starting point of the life cycle of this transformer, when it was in the factory or it was commissioned at the substation, to the very end of its service life. So this is the trending. And now, what is important to trend? How do we trend? And is this the information that we really want to look at? Well, that is a different question probably, and we need to develop that a little bit more, because there are many things that could and should be trend.
That was actually going to be my next question. So you've explained to us what the context of trending is, but what should be trended?
There are many things that could be trended. Let's say from the electromechanical point of view, right? Just fundamental testing that we do, like ratio testing, winding resistance testing. We can compare those values with previous values. We can compare those values with factory values. We actually do comparative analysis between different phases. But mainly, when we look into trending characteristics, we look into dielectric system and chemical components. So I would say the most common practice is to do trending analysis on power factor or dissipation factor testing. The other practice that is very common is to do dissolved gas analysis, right? And look at the historical process of aging, which gases have been developed during the operation of the transformer. There are some other parameters that we will be trending, of course, like moisture inside the insulation. That is a very, very, very important factor that needs to be observed and monitored properly. And as we can say that not only that, but there's, advanced testing or more life-related tests, like we have like furanic compounds or methanol, things like that. So there are things that we can absolutely observe from day zero, as I said, till the end of the service life of the transformer.
Yeah, so there sounds like there's actually a lot you can do when it comes to training and transformers, but I can imagine with that might come a lot of problems. So what problems might you run into when trending?
Very good question. And it's probably very difficult to answer on every specific test.
Yeah, we don't need to go into every test. That might take a while.
That may take, several chapters.
This will be a long episode if we did that, right?
Long episode. But let's look into the most common tests, right? For example, oil sampling, right? And dielectric breakdown testing or tan delta testing on liquid insulation. It is very important how you take the sample, right? And to measure the temperature so you can make a reference to certain temperature for the proper diagnostics. The other one that is very common is dissipation factor testing. So we will look into the temperature of the insulation. Sometimes it's a difficult task to define the temperature in the insulation system inside the transformer. But we look at this information, we do the measurement, and then we need to normalize it to a temperature that could be compared in the future to a test that was performed, let's say, at 10 degrees C or another one that was tested at 30 degrees C. We need to normalize that. So in that specific case, if we don't have a good method to do the normalization part, you will be way off.
Yeah, it won't even be worth doing at that point.
It may take you anywhere but to the right decision.
So I think it's important to put this in real life context. Let's step out the theory for a minute. And you've been in the industry for a long time, so I can imagine you've seen quite a lot. So in the context of real life and trending, can you explain to me a scenario or somewhere you've been where actually trending has become an issue or come into question?
Absolutely. Good question, Darcy, because when you look at things, and what most of the people has been doing so far is doing this normalization part, right? Based on average tables, right? And that is one of the problems, especially for this trending analysis. So I was telling you something about aging, right? And I was telling you that aging may affect the dielectric characteristic of these components. So just imagine that you have, for example, on a power transformer, let's say you have 3 bushings with the same nameplate, same characteristic, same manufacturer, everything looks the same. But now you do an analysis, a dielectric analysis, and you, let's say, measure power factor or dissipation factor, and you use the same table for all of them. But one of those has degraded. One of those is going in a different process because of whatever reason was, right? now your assessment is completely different, because if the dielectric response has changed, the thermal response has changed. And because of that, you cannot use now any kind of average correction factors. You have to measure it. You have to see what is the dielectric signature on that specific specimen. So we have seen things where everything tested good, right? And it failed. Why did it fail? That is the key question. Why did it fail when everything tested good? Maybe because we did not understand exactly what was beyond that simple test, right? There's more to see. There's new spectrums to look at, and there are ways to correct it properly.
And I suppose good testing only comes from when you don't rely on that singular test and you have a whole bunch of data from multiple tests to work with, I guess.
Oh, that is a combination of tests, right? Absolutely. You can say that no one single test will tell you the whole truth about the condition of this transformer. That is absolutely correct. Taking different tests, of course, helps you with the validation process, right? And sometimes if you are doing the proper trending again, right, takes you to the right answer, sometimes may not. You can compare, for example, your dissipation factor testing with some DGA analysis, right, dissolved gas analysis. You can compare with some dielectric frequency response testing, right, looking at the dielectric system in the full spectrum. All those tests, right, will help you better understand what the condition of your transformer is.
And so let's touch on testing and actually physically testing a transformer. When it comes to trending, what's available on the market now so people can get the right tests done, get the right data, and do trending accurately?
Well, nowadays, you are able to look just beyond the typical line frequency dissipation factor, for example.
So much more than just that, right?
So much more than just that. There's so much more. And even with the same power factor test set, what we have now is what we call the narrowband dielectric frequency response, which allows you to go from 1 hertz all the way up to 500 hertz. And that gives you a much better perspective of what you have inside. That helps you see, visualize what is the true condition of the dielectric system, what the changes have been. And that would allow you also to apply what we call the individual temperature correction algorithm to really normalize according to that dielectric signature that you have measured. So there's much more now on that. And I think that we have presented several examples, and we have worked with many of our customers, and everybody is really getting into this understanding of proper normalization by the individual temperature correction and looking beyond just line frequency dissipation factor.
And you think the people that you've worked with have been open to doing that? Because it's obviously going a step beyond maybe what the normal testing regime may be. So they're happy to put in the extra work. Are you getting good response?
Well, that is a very good question, because how much is extra work, right?
Very true. You can never work too hard for safety.
Is it too much? Is it really too much? So let me tell you, Darcy, this way. If I ask you to spend 2 more minutes on your testing, is that too much work?
I don't think so.
If you don't have to disconnect...
I was about to say, if I'm already connected and hooked up and I've just got to press a button, I'm doing it.
Exactly. If you have everything already connected to your transformer, right, and it takes only 1 or 2 more minutes of your time to get the full spectrum or to get the better analysis, will you say no to that?
Absolutely not.
So think the same way that we're thinking about it, right, from Megger, we want to help our customers to be more effective and efficient in the field, right?
Yeah, it's the ultimate goal.
And time is critical. So you need to look at that, and just by having the same tool, right, with expanded capability, right, with expanded spectrum of frequencies to look at, I think that is a great advantage. And our Delta 4000, our trucks with the TDX, those will take care of that absolutely in the best way.
So we know that trending is only as good as the data that you have. So how would one go about actually validating that data to make sure it's correct?
Very good point. And sometimes, let me put it this way. You can have the data to look at the past, right? And maybe even work on some forecasting, what will be the future, right? And you can be like the Weather Channel guys. There's 50% probability of rain, 50% probability no rain, and you will be always correct.
Yeah, exactly. You're never wrong.
You're never wrong. But the data that you have might belong to a dedicated database. And if you're a service contractor, especially when I talk to service contractors, they come to the field, they come to test a transformer, but they don't have access to that data, right? So trending is not available
Yeah, they don't have the
all
data
the time. So how do I validate that the number that I'm measuring today, is good or bad? Because it may look good under the limits of the acceptable standard, but is that really good? Is the temperature factor changing, modifying it, shifting it, to different frequencies? How is it working? So the way that we do right now is when we do the dielectric dissipation factor, we do the line frequency and we use 1 hertz as well. So with that, we may need to say thank you, but no, I don't need the trending part, because now I have a point of validation. I can see what's going on with my specimen. And different pieces of equipment may have different failure conditions, right? And you need to understand this. On some pieces of equipment, it's easier to understand when we look at the 1 hertz and the 60 hertz or 50 hertz line frequency value. For other pieces of equipment, let's say RIP or RIS bushings, you may want to look into the 60 hertz plus, up to maybe 300, 500 hertz. There might be things that will pop up on that spectrum of frequencies. So having the ability to look into below 60 and above 60 is really a great feature for the field guys.
I want to talk about the standards bodies and something that they're trying to look into, which is efficiency trending. Can you tell me what your point of view on this is and why you think they're trying to do this?
Well, efficiency is a big word. Let's put it that way. I think that everybody in the industry is looking into efficiency as a target. Everybody is looking.
It's the ultimate goal, isn't it, really?
It's kind of an ultimate goal. And one of the things that you need to understand is the transformer is a very efficient machine, right? It's extremely efficient machine. But if you want something more efficient, there's a price for that. Okay, so you can go into much better magnetic materials. You can get into some more efficient, maybe insulation materials. You can get into a better cooling design. There are different things that can be improved, but everything comes with a cost. And cost right now is something that everybody, every industry, every utility needs to manage. But going to the standard boards, there's a process right now, together with the IEEE and IEC, trying to synchronize ideas on efficiency. And there's a mandate as well from the European Union, to get into more efficient systems and to look into the efficiency of the transformers. So efficiency is something that we will need to look at carefully on our transformer, from the point of view of designing it, from the point of view, if you are a buyer, how do you specify your transformer, the efficiency of it, and how is it going to be looked at during this service life of the transformer. So you're going to have to do a little bit of trending and see that things are keeping the same way.
And trending is probably very important to holistically see what the efficiency of the transformer has been and might be in the future. So it's a good collection of data to have and point of view to see.
And maybe it's also a way to understand that if there is any change in my transformer, right, how the efficiency will be affected, right? It could be a change, an electromechanical change, right? That might be detected by a simple test procedure. It might be something more complex.
So to tie this all together, Diego, and I think you've given us a great overview of trending in transformers, what is the moral of the story here? What's the one thing you want our listeners and watchers to take away?
I want people to understand that the transformer goes through a life cycle, right? It begins at a certain point, it will end at a certain point. There are different things that we can do to look at, to monitor the service life of the transformer. Some of those, of course, related to the dielectric point of view. Again, what is aging inside my transformer is directly related to the insulation system. Organic materials, paper, and oil. Oil is the one that gives information, mainly. When you are online, when you're in service, you can take a sample. Make sure that you have a good sample, that you know how to take that sample, right? And if you do offline testing, especially your dielectric test, make sure that you apply proper correction factors. Make sure that you know how to normalize it in the right way. Otherwise, you will be off track. So I would say that the objective is trending. Yes, can be done, but it has to be properly done. And if you do not have historical values, you need to validate. You need to validate, and you need to make sure that you are not based your decision just on one single parameter. Of course, you don't do just one test. You don't perform just one test. But if you're looking, for example, into dissipation factor, do your line frequency, 50 or 60 hertz, but also validate with an additional frequency. And what we have been promoting is the use of 1 hertz. So look at those two frequencies, spend a couple of more minutes, 2 more minutes on your testing. Same connections, same piece of equipment, everything is there, and thumbs up or thumbs down.
Yeah.
Yeah.
Thank you so much for being on with us today, Diego. I hope you enjoyed it.
I enjoyed it so much. Thank you so much to you, Darcy.
No, thank you very much. And thank you for watching, and thank you for listening.